In this video, we will continue to look at the input buffer operations, and in particular, we're going to concentrate on using GetLine to input the entire line of data, and then we'll use our string processing functions to extract the parts that we want. This time we'll start with really the same program we did in the previous video, and in fact, I have left case 1 exactly as it was in the previous video. So this will be a continuation of that program. We'll move on to case number 2, and here you'll see that we have exactly the same input that we did previously, but instead of using cin to input the data, what I want to do here is to use GetLine instead. With GetLine, you can input an entire line, including any spaces that might be between items that you type in. So GetLine is going to empty really the entire input buffer into a variable within your program. And the way we format that is like this. We just use GetLine, that's the function, and we use cin because that's our input stream, and the variable, which is a string type that I'm going to store the data in, is called line. So this will read in the entire line, and to prove that that was the case, let's print that back out again. Okay, double quote, the input buffer contained, okay, a double quote, and we'll print out line with our end line afterwards. So this will just reflect to the screen the information that we read in, and when I run the program, you'll see that it is exactly all of those items shown here between the double quotes, including the spaces. After we input that line, we're going to use some of our string processing functions in order to pull out the information. So in fact, the statement here in the comments, let's close out some space, it says we need to get the numeric items from the string variable line. We need to extract the characters and then convert them to the appropriate type. The thing that's going to be a problem for us when we use GetLine is that GetLine pulls in everything as a string type. But within that string, there are some numbers like 1, 2, 3 for our integer value, and 3.45 as a real number. So we'll need to pull those out and convert them from a string type to an integer type for this, and a real number, which is a double for this type over here. The other things we can just keep as strings. A, B, C, D is a string. We've been putting that into part 1, so that's fine. X, Y, Z is a string. We've been putting that in part 2, so that's fine. And this little colon in the middle, well, that's just a character that doesn't need to be converted, so it can stay as is. What we need to do now is just to begin to extract all of these various parts. So for part 1, I'm going to use the substring. Actually, I'll be using substring for all of these. And the position, and we can just count these up here. If we just, this string is so short, we know that the A is in position 0, B is in 1, C is 2, and D is 3. So if I want to extract just that A, B, C, D, I would start at position 0, and I would get 4 characters. So that will extract that information and put it into part 1. Now, if I want to move on and get the number 1, 2, 3, then I have another variable, which, since this is going to be a string, I need to have a string variable for this. So I'll scroll up and show you that I have declared 2 additional variables. They are type string, and one is called s_number, so that's a string for the number, and the other one is a s_realNum, which is a string type for the real number. So I have a string type for those characters, but I'll need to convert them to an integer and to a double, and that'll be an important part of this video. So there's part 1. We will import that, and we won't need to do any conversions because it's already a string. Now as I go, I want to add comments about each one of these. Okay, so this will get the substring A, B, C, D, and save it in the variable part 1. Okay, now let's go get the number. And I want to get the string number this time, so it's the string version of our number 1, 2, 3. So s number is going to be equal to line dot substring, and I need to note the position. So if I'm counting again, I know that A is at 0, B is at 1, 2, 3, 4, and the 1 begins at position number 5. Right? So I'll just put in position number 5, comma, and I know that the number has 3 digits, so I'll put in a 3, and that will extract the string version of 1, 2, 3. So this will get the substring, I'll put double quotes to emphasize it, 1, 2, 3. Okay, now we can't compute with it like that. We'll have to convert it. And here is one of the important lessons of this video, is how do you convert something that's a type string into something that you can compute with? Well, the number, the variable number, is an actual integer value, an int, and that's a computational base 10 number. It's not a string. I want to convert my S number and store it into my integer type number. And there are functions provided to do that. The one that I want to use here is called stoi. Now that stands for string to integer. Then within parentheses, I put the variable containing the string, which is S number, right paren and semicolon. So this is the conversion. Okay, convert string 1, 2, 3 to an int 1, 2, 3. There are other conversion functions. There's an S to D, S to F, S to U, and so on, that will convert strings to the other types that you're familiar with, like float, double, and unsigned. That is taken care of the part 1, and that's taken care of number. Okay, now let's get the colon. Okay, colon is easy. We can use the at for that since it's only one character. Okay, so the colon is going to be equal to line dot at, and I need to get the position again, so let me go count. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the colon looks like it appears at position number 9. Okay, so that will read the character variable colon. So we're going through this input. We used GetLine to read in this entire line, and now we need to break it into the parts and assign it to the variables that go with those parts. The next thing that we need to get will be our real number, the 3.45. So as we did with the integer, we need to have a substring containing the real number. So that is, I'm going to use variable s real num. So that's a string type, and that will equal to line.substring. And the position for this, if you count over, the colon was at 9. Okay, so that's 10 for the space, and 11 will be where the 3 begins, and it has 4 characters including the dot. So the substring for this part is going to be at position number 11, comma, and we need 4 characters to read in. So this will get the substring. Again, I'll emphasize with double quotes, 3.45, and save it in s underscore real num. Now let's correct my typing, make that save. So this will pull out the substring, but it's still a type string, so we need to convert it. So real num is my type double, and I'll say that is equal to s2d. That stands for string to double. Parentheses, and the variable that contains the string is s underscore real num. Okay, so let me fix my typing. And I'll put a comment here that we want to convert the string s underscore real num to double real num. So that's what that will do. Now we're almost finished with this. We still have the x, y, z on the end. and I need to pull that out from the variable line. Okay, so those are the last three characters. So going back up here again, I know that the three, it's 11, 12, 13, 14, 15. So it looks like the X is going to begin at location number 16. And we only have three characters. All right, so part 2, which is a string, is equal to line.substr, position 16 and 3 characters. Okay, so that will get the string, the substring, double quote X, Y, and Z, and save it to part 2. At this point, we have taken apart the variable line, and we have stored all of those parts into part 1, number, colon, real num, and part 2, as we did previously. Now that that is all finished, I already have the cout statement shown here, which will print out all those values. Okay, so let's see if that worked. And I noticed that I don't have a system pause here, so let me add one so that it will stop at this point. Okay, now that will let our program run down to this point, and then it will stop. All right, I'm going to build the program and run it. Here's the window, and case 1 is popping up here, and that's the same as we did in our previous video. So let me go ahead and type in the information as requested. Now, when I hit enter, then you'll see that all of those items are read in, and they're stored into the 5 different variables. Now, moving on to case number 2, which we just did. Okay, we had an error when I did run that, and the reason that I had an error is because after doing case 1, what I should have done after inputting all of this, or attempting to input it with cin, I need to make sure that there is not anything left in the input buffer before we move on to case number 2. So in order to clear out anything that might still be left in the input buffer, I need to put a GetLine here, cin, comma, line, close that in semicolon, and this will make sure that there's nothing in the input buffer. So I'll say empty the input buffer. Now, what was really still in the input buffer was after I had entered this for case number 1, at the very end of this line, even though it isn't visible, when I hit the enter key, there's a \n, or an end of line marker, that's still in there. So after I've done all this, that end of line marker is still waiting in the input buffer. So this will clear that out and will not cause me problems when I move on to case number 2. And we'll see this same thing showing up in some videos that will be coming up soon. Now, let's try this again. So here's case 2, and we have all the stuff there that I just typed in. So we've read the line in with GetLine, and we've pulled out all the parts, and then we're going to print those to the screen here. Okay, so let me recompile this, and then we'll run it again. Now, here we have the window popping up again, so now we need to enter the data for case number 1, maybe CD 123 colon 3.45 XYZ, and I type enter, so that's case number 1. And now I've added the GetLine to this to clear out anything that might still be left in the input buffer, and we'll move on to case number 2. And case number 2 says we are to enter the data again exactly as it's shown. Maybe CD space 123 colon 3.45 XYZ. And then when I type this in, then you can see that the input buffer contained all of this information here. So again, let's look at the code for this. That's printed out because I did the GetLine. So let's scroll back up and look at where I did that. All right, so after I type in the information, I do a GetLine. GetLine is going to read in all of it, everything, all the way through. So then I print this back out, and I say the input buffer contained everything. So that's the line. So that's what you see here from this statement. Input buffer contained ABCD 123 colon 345 XYZ. So that's what I'm getting from here. Then we go through our various substring operations and we pull out the pieces individually, and then we print them out with this cout statement. And that is what you see down at the very bottom. After input buffer contained, then we have pulled out the ABCD, the 123, the colon, the 345, and the XYZ. The thing to remember in this video is that I'm using GetLine to read in everything from the input buffer. Once I do that, everything is stored in this variable called line. So that's a string variable, and it contains all of this data. So this is one technique that you can use if you have multiple things on a line. You can read in the entire line as a string, and then you can parse out the various things using the substring operations. And if you have a string that needs to be converted, like in the case of snumber, then there are functions called s to something, s to I, s to d, s to f, which will take the string, substring part of that line and give us the ASCII encoded string type value, and it will convert that to the computational integer value number. And that's what we did with number, that's what we did with real number. And then we did print out all those things here at the bottom of this cout statement. Now I have one more case I want to go through before we get to the end. And that is, let's type in the information without any spaces, and let's use the same technique in order to extract everything. So that's what I want to do. And in order, once again, to make sure there's nothing left over in the input buffer, when I finish all of this input up here, what I'd like to do is to just insert another GetLine. And even though I did a GetLine to get this stuff, so it shouldn't be a problem, but let's make sure. It never hurts to make sure. So if I do another GetLine here, then it will read in anything that might be left in our input buffer before we proceed to case number 3. So once again, this will empty the input buffer. There will be some other functions that we'll see in the next video or the one after it that will give you a different technique for clearing out the input buffer. Well, okay, let's move on now to case number 3, and the only difference will be that we will not put any spaces here. So we're going to do a GetLine, and this will read in the entire line. So input the entire line, and it will be saved in the string variable line. Then we want to do the substring operations in order to get the data out. This is very similar to all of these operations that I did in case number 2. So let's save a little bit of time and just copy this part of the program where we get part 1 number colon real number part 2. So let's start by copying that, and then I'll just need to change the numbers in the substring functions a little bit. So I'll copy that whole thing, and after the GetLine I'll paste it in, and then we will do some editing here. Now, as we did before, let's print out our input. So let's do cout. Okay, line contains, okay, colon, double quote, and let's print out the value line. Okay, so we can see that. We can see what was input by this GetLine function. Okay, now let's go through and let's do all the substrings, and we'll need to modify the counts a little bit, that is a position, because there are no spaces this time. Okay, part 1 is still fine because the A is at position 0 and it has 4 characters. snumber, however, is going to begin, and if you count these, we can go A at 0, 1, 2, 3, 4. So now the substring for snumber, that is the 1, 2, 3, is going to begin at position number 4 instead of position number 5. It's still 3 in length, so that's okay. This will be retained once again. We'll convert it from a string type to an integer. The colon now we'll have to change that from a 9, and if you count across, let's do that one more time. 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so it's at position number 8 this time, if I counted correctly. And we don't have to make any changes to that because the colon is just a character value. Then if we move down and we want to get the string part of our real number, then instead of starting at position 11, then if you want to count across yourself to check it, then this is going to be at position number 8 this time. And in fact, let's go count that to make sure it's correct. Okay, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8. So you see that the cursor is right to the left of the 3, so that means that we're at position number 8, and that's where the number 3.45 begins. Okay, so if that's 8, and we move forward, that's 9, 10, 11, 12. So the the last part will be at position number 12. All right, so we'll convert the s real num, which is a string, to our real num and print that, or prepare to print that out. And finally, that leaves us with the xyz at the end, and we just counted across, and we found that the x starts at number 12, position 12, so we'll get that substring. Then we will print all those parts out to the screen. Right, let's build the program and run it. Here's the output screen, and I've gone ahead and entered the information for case 1 and case 2, so now we're ready to take care of case number 3, which was the last one we did. And this time we'll type in all this information with no spaces. Alright, so there it is, and then when I hit enter, then we will look at the output. So once again, we print out the value for line after we do the GetLine. Let me scroll down so we can see that. Alright, so no, I have to scroll up, I guess. Alright, so here's the GetLine for case number 3, and then we print out the line contains. So that's where we get that complete input buffer content. So line contains all of that. And after we do the GetLine, then all of the data has been pulled in from the input buffer. It's saved in the variable line. Then we go through with our substring operations and we extract the various parts. Okay, so we get ABCD, we get numbers 1, 2, 3. Let's take a look at this. Look, the colon comes back as number 3, so I miscounted on that one. Real num is 3.45, that's correct, and part 2 is XYZ. Okay, well, let's go fix the colon, but as you can tell, this works pretty well. We can just input an entire line, and then we can take it apart piece by piece. So I'll terminate this program, and let me go back and fix the problem with the colon. So I have number 8, so let me recount, and I'll fix that. Okay, so A is at 0, that's 1, 2, 3, 4, 5, 6, 7. Oh, I think I know what happened. I think I failed to type it in. But let's try it one more time. Okay, so I did miscount. Colon should be at position number 7. Okay, so now I can recompile and we'll run it one more time to make sure. I started the program, and again I've entered the data for cases 1 and 2, so we're down to case 3. Let's try this one more time. Alright, now the output looks correct. So we have part 1 is ABCD, number is 1, 2, 3. There's the colon. It really is a colon this time. Real number is 345, part 2 is XYZ. And we can close the program. So this program illustrates a technique that you can use if you have some information, again, that is a bunch of letters and numbers that are all together. If you need to read those in as a unit, then you can use GetLine to do that. Then you can use the substring functions to pull out the information, and anything that has to be converted from a type string to a number, you may do that by using the stoi functions. So they're stoi and std to go to double in this case. And remember, there are others, s2f to go to floating point, and so on. So you can look those up if you need to do that. Okay, I think that's all we need to do here. So this will conclude the video.